All right, let's go ahead and get started, everybody. So welcome to the 2025 Forest and Climate Learning Exchange Series. Today we have a panel featuring Matt Hurteau, Bill Anderegg, Chris Galik, and Rebecca Sanders-DeMott talking about permanence. And we called this one Identifying Forest Carbon Offset Permanence Research Priorities. So this year's a little bit different for the Learning Exchange Series for those of you who have joined us in the past. So we are taking a panel approach where we really want to bring together different kind of thought leaders, experts in the field to not only discuss various barriers and gaps to certain research questions, but identify some kind of priorities and paths forward to increase the amount of efforts we have to actually reduce greenhouse gas emissions using forests as natural climate solutions. Before we get started, I have a couple intro slides. So first of all, I would like to thank our co-hosts for the 2025 Forest and Climate Learning Exchange Series. So we have this year, the Society of American Foresters, which is a national scientific and educational organization representing forestry and related natural resources professionals across the United States. Founded in 1900, SAF promotes science-based sustainable management and stewardship of our nation's public and private forests. Joining us this year as well, we have support and co-hosts from the FOSSE program, which is a Forest Owner Carbon and Climate Education Program. This is a collaboration of 13 university extension divisions and 3 USDA climate hubs that seeks to educate forest owners and practitioners about forest carbon and climate smart forestry. The program prepares forest owners to engage in forest management and the carbon economy by creating resources about incentives and opportunities, such as forest carbon markets and government programs, and providing tools to help guide the planning around forest carbon and climate change issues. Penn State Extension is the lead on this project, and I will be putting a link in the chat to learn more about the FOSSE program in a minute. That takes me to kind of the rest of our panels coming up. So this year we have 6 panels, a part of the Learning Exchange Series. So today is obviously our first one on permanence. Our next upcoming one is February 25th on additionality. You can register for that webinar now by following the QR code on your screen. The last little bit of information is that this is a panel webinar, so there will be a time for audience Q&A. There is both a chat and Q&A function enabled for this webinar. So if you have questions during any point of the panel, feel free to drop them in the Q&A box on the screen, and we will do our best to address all of the questions. Last thing I have is a QR code for the Forest Carbon and Climate Program mailing list. I guess I forgot to introduce myself as well. So my name is Chad Papa. I am the director of the Forest Carbon and Climate Program here at Michigan State University. And we, again, are the primary hosts for the Forest and Climate Learning Exchange Series. And so with that, I'm going to hand it off to our moderator, Matt, who is going to moderate the panel for us today. So again, panelists, thank you for joining us. And I look forward to the discussion.
All right, thanks, Chad. Good afternoon, everyone. So I'm a professor at the University of New Mexico and director of the Center for Fire Resilient Ecosystems and Society. Today, we're going to be discussing permanence in forest carbon offsets. We've got a great panel of folks, including Christopher Galik from North Carolina State University, Rebecca Sanders-DeMott from Clean Air Task Force, and Bill Anderegg from University of Utah. All the panelists have done a lot of thinking about forest carbon offsets, including some of the challenges around permanence, and I'm looking forward to our discussion today. So when a molecule of carbon dioxide enters the atmosphere, it can remain there for anywhere between a year and thousands of years. And in an effort to make carbon sequestered in forests fungible with fossil carbon left in the ground, offset protocols typically require that the carbon be stored in a particular patch of forest for some predetermined period of time. So this permanence period ranges from about 25 to 100 years, depending on the program. If forest carbon is prematurely released from storage within a project area, it's considered a reversal that typically requires that the system is compensated for that. So a common mechanism used to compensate the system following a reversal is the buffer pool of offsets maintained by the program. And so this is like an insurance scheme where each project contributes credits to the buffer pool based on the reversal risk of their particular project. And so my first exposure to these concepts was as a postdoc when I read what was then the California Climate Action Registry's Forest Protocol. And it treated wildfire emissions as beyond the control of the project developer. It was almost like an act of God, and you just wrote that loss off the books. Since I had just finished my PhD studying, among other things, fire in California's forest, I was pretty amazed that these fire-adapted landscapes, that a protocol designed to operate in those fire-adapted landscapes did not include an expectation that disturbance would occur, nor did it account for the fact that in many of the forest ecosystems in California, management can alter fire effects on the system and can alter the potential loss of carbon to wildfire. And so that led to the first paper that my colleagues and I wrote on the topic, looking at kind of the trade-offs in terms of managing high severity wildfire risk and carbon, and then evaluated the potential changes in total emissions from 4 large wildfires across the Western US. And so, we published that one in 2008 and have done a lot of thinking since then on this topic, primarily as it relates to carbon dynamics, forest management, and wildfire, sometimes other disturbances as well. And really the punchline from all the work that we've done is that in these fire-prone ecosystems, stabilizing carbon through management rather than seeking to maximize that carbon, stored per unit area leads to increased carbon storage over time. And so, that basically my experience in fire-prone forests has really shaped the way I think about this. And each of the panelists today and the work that they do and the way that they think about this particular topic and the topic of offsets in general has really influenced the way that I think about this topic as well. And so I'm really looking forward to hearing what they have to say in our discussion ahead. And so with that, I'll pass it over to Christopher.
Thanks, Matt. I appreciate that. And I remember first reading that paper you mentioned all those years ago. I was like, I should give this guy a call. So I appreciate your work in this space. I appreciate the invite to be here today and to share a few minutes and a few thoughts on the topic. It's definitely an evolving thing for me. And so I am going to share my screen. Should all be seeing what I'm seeing now. Okay, so again, I want to talk a little bit about what I call the changing faces of permanence. And this is from my own experience, a little bit like this is my research life kind of thing, a little retrospective on the last few years. Melissa, your hand's raised. Is that a question for me? Okay. So coming up on some 20 years ago now, we were really trying to drill down into the actual amount of net tons a single stand was generating, getting to Matt's point about fungibility. And to do that, we did our best to get the individual parameters right, demonstrate strong additionality, calculate baseline the right way, use the right deductions for leakage and uncertainty, withhold the right amount for the permanence buffer that Matt just mentioned here. But as we saw in the sum total of the exercise, and that's shown in the figures right here, the number you get really depended on the protocol you used. All these data came from the Calhoun experimental forest. So the only thing that changed, the variation you see here, is all due to the rules we used to calculate how much carbon could be offered for sale. We called this creditable carbon in the paper. And there's a ton of variability, no pun intended there, but many of these programs and markets aren't even in use anymore. I mean, we could talk about impermanence in that context, and Chicago Climate Exchange, for example, looking at you here in the figure CCX. So in recent years, we've been digging a little bit more into the permanence question a bit more, as we found in some of the work that came out about a year or two ago. We get a good deal of variation, even when we just look at some of the more contemporary approaches for handling permanence, not just buffers that were mentioned already, but other accounting approaches used to ensure project integrity, like 10-year accounting and shorter term for these projects to be registered over. So what we see again is a lot of variation between not only what type of approach we use, buffer or these other types of accounting approaches, but also across forest types, that the relationship between these different approaches changes based on what type of forest you're operating in. So again, the question really emerges as to what is the right approach to use in this context. But of course, it's not even that simple. So these approaches are designed to ensure system integrity, right? Like the things that Matt was already talking about. So if we start introducing some stochastic events into the equation, talk about fires and wind, we find a few things. First is that the length of the project matters. So if we have long periods of time, we're obviously subjected to more events potentially occurring. So the longer the project, the greater the chance that something bad happens. But it also matters the way the projects are arrayed too. For example, we found a large number of smaller projects is more robust than a single large project. Usually the large project does okay. So if we have 40,000 acres, for example, we could have one big project, or we can have a whole bunch of 1,000 acre projects, adds up to the same amount of acres. What we found is that in the larger project, it usually does okay. Okay. But what we found also, however, is that sometimes things go south. Sometimes we get situations where the system is overwhelmed. We have such a large disturbance that the buffer collapses. And so again, we're facing this question of what's the right number to use? What's the right way to account for this stuff if it matters what protocols we use, if it matters what forest type we're in, if it matters what type of accounting approach we use, and if it matters, well, just what happens on that land over that period of time that we're expecting it to be around. And I'm sitting here thinking about this, that we tend to treat things as permanent that are literally falling down all around us. And I call this reminders of the endemic nature of impermanence. An oft-used average lifespan of a house in the US is about 50 to 60 years from construction to demolition. And we can look to other things that are happening again all around us right now, whether it's the horrible tragedy unfolding in Southern California as we speak, or a year and a half ago, it was a catastrophic fire in Maui. Elsewhere, we have sea level rise and community relocation occurring. So even the things we think about as being permanent are not guaranteed, and in some cases, not even expected to be around for the 100 years that some protocols expect carbon projects to last. So given all this, I have more questions than answers. And so that's one of the reasons why I'm excited to be here talking about future research needs, because I think they're everywhere. So again, permanence continues, in my opinion, to face the challenge of one, setting the right accounting approach, and within that, getting the right parameters in place. So given that age-old tension between overcrediting and undersupply, okay, how do we ensure a system that has integrity, but also ensure that the system is able to, and landowners are willing to participate or gain the participation that we can actually generate these tons to contribute towards mitigation of climate change? Are there new ways to think about permanence, particularly ways that are not done on a project by project basis? So not requiring individual lands to calculate their individual contributions, but rather looking at the system and trying to parcel out who's responsible for what after the fact. Not projected, but rather, again, awarded incremental benefits based on what's already been achieved, and acknowledge the endemic nature of impermanence, viewing incremental gains in the context of a constantly shifting natural and physical and frankly economic environment. It's all really, really hard, I think, but I think there's ways to leverage data and technologies that we haven't before. Some markets are attempting this at the margins, but I think this is going to require a sea change in the way we view carbon and frankly other ecosystem services, using AI, remote sensing, perhaps even big data and citizen participatory science in ways we haven't before. Again, I don't have the answers, but I'm super excited to be here and be a part of this conversation and look forward to the discussions that are to follow.
Thanks, Christopher. Now we'll pass it over to Rebecca.
Great, thank you. Let me just get my screen popped up here. myself reoriented. So hi everyone, thanks for having me. I'm an ecosystem ecologist and director of ecosystem carbon science at Clean Air Task Force. We are a nonprofit advancing resilient solutions to climate change. And my work is, I have this screen shared, right? This is, okay. My work is focused on opportunities and appropriate ways to incentivize managing land and systems for climate mitigation and resilience. And as part of that, I led a review of what current carbon credit issuing registries and compliance markets in North America are requiring today for certification of carbon credits, including how they're tackling permanence. And that paper is currently under review. So together with a team of forest science experts from across the country, including Matt and Bill, we identified and evaluated the approaches to permanence being used. And there is, as Christopher indicated, still a lot of variability in the existing system. And so from 20 protocols, there's sort of a lot here, so let me walk through a little bit. We broke out how they handle all of these different features of permanence. So the length of the monitoring period, the structure of risk mitigation, for example, buffer pools, but also risk screening, 10-year accounting, how the buffer pool is capitalized, where that is used, and then specifically how fire risk is considered or insect and disease risk for buffer pool contributions, and then how frequently and to what extent risk is reassessed over time. And so over here, we have all of these individual approaches are different rows here, which aren't all listed out. But there are many of them, and they were all scored by these experts, with the distribution ranging from fundamentally flawed approach to an exemplary approach. And you can generally see how the spread was with bluer colors indicating more experts scoring these as robust, and they've red and yellow and orange showing weaker scored approaches. And we have a lot of approaches in this sort of weak area. And I pulled out just some of the best and the best scored and lowest scored approaches to give you a flavor for kind of the differences that are out there today. So our lowest scored approach for the length of the monitoring period was actually just a 10-year period where there's credits being issued and monitored for a 10-year guaranteed period of time. On the other end of the spectrum, you have certain systems that require 100 years of monitoring for every credit that's issued. Really, really different. For this fire risk, for the fourth row down here, our lowest scored approach was just assigning a default 4% risk value to any project that's certified, whereas a more strongly rated approach was using a spatially resolved sort of ecoregions and prescribing a value that was also much higher based on characteristics of that ecoregion. And then on the last row, there are some protocols that just fix the risk rating once the project is certified at the very beginning, and it doesn't ever have to be revisited. Others require that risk rating be reassessed at every verification cycle. So there's just a real diversity here. Our team also came up with many actionable recommendations for strengthening these protocols and moving them forward. And these are just the ones specific to permanence and market structure. I just do want to highlight, though, that sort of all of these lend to the idea that there are data and methods that exist right now to increase the rigor, the consistency, which I think is really important, and the transparency of these protocols. And I think, opening up the discussion about research might point us in the direction of how to do that. And finally, I want to put the permanence discussion into context a little bit, because we know that forest carbon isn't permanent in the way that fossil fuel emissions to the atmosphere are, or even carbon stored in geological sequestration. And so this figure comes from the Oxford offsetting principles, and it highlights this idea of a shifting portfolio of investment in climate mitigation over time. where these green bounded ones include, credits that might be issued from forest management. And so thinking about what our needs are for climate mitigation over the long term may also change the sort of ideas that we have for what's required for permanence for some of these credits. Because I think forests are absolutely critical to helping stabilize climate, and we just need to better recognize what forest carbon credits as a tool can and cannot offer, value them appropriately in a way that recognizes this changing need and options available over time, account for them properly towards targets, and then use the data and tools available to make them as robust as possible. So that's all I've got for now.
Thanks, Rebecca. And now we'll pass it over to Bill.
Hey, well, thank you all. It's a pleasure to be here. It's fun to follow Rebecca and Christopher and Matt here. So I'd like to share a little bit of our work, and it looks like a fantastic series that's coming up. I certainly think I sort of view these 4 core: additionality, leakage, and durability as being really crucial and things that science can inform. And one other one that I'd like to just put in a very quick plug for is accounting for the net climate impact by including things like albedo and biophysical impacts. And that's, I think, very underappreciated in carbon markets right now. In any case, these durability risks, I think, really come in these kind of natural pieces about climate and disturbance. And we've talked about fire. There's also substantial social risks that have to be kind of considered within a buffer pool or an insurance approach as well. And I think this is a really important challenge for the field is, can we actually come up with evidence-based, data-based risks of these different pieces that really capture it over longer periods of time? So a lot of the work we've been trying to tackle are, what are the main risks and how do they vary over space and with future climate change? How large should buffer pools be to ensure durable carbon storage? And can we really kind of develop open source tools to improve the durability and permanence assessment in these protocols? So where we started was really trying to model some of the core disturbances here in the US based on FIA data and satellite data. This is looking at these kind of long-term projections in different climate scenarios in different regions of fire on the top, drought and other climate stress that's not fire, and insect-related tree mortality on the bottom. And of course, there's huge variation over space, but all of these cause substantial losses of carbon in US forests and are generally projected to increase in many regions. So then we worked to fold this into a more carbon-centric model that captures growth and recovery after disturbance. This is work led by a former postdoc in my group, Chao Wu. And we compared a couple different techniques, but I'm showing you kind of the most robust technique here on the map on the left is where we expect, even in this mid-range climate scenario, the areas in red to lose carbon and the areas in blue to gain carbon over the 21st century. And then these histograms on the right are California's compliance current offset projects. What I want to highlight is this is the rightmost one is by acres affected, that in this analysis for these models, which is really a pretty conservative, better case scenario, at least 36% of the acres in these existing offset projects are projected to end up with less carbon at the end of the century than they have today. Now, that doesn't get you all the way to something like an insurance pool or a buffer. We've been trying to do some global risk assessment as well. So this is one of our syntheses of global climate risks to forests. But what I want to show you is some of the work that's in progress that is in review now and hopefully will be out soon to help inform things. Or we could actually now leverage these models to calculate how big do the buffer pools need to be in the US. We can have really detailed maps because we can draw on things like FIA. And globally, we can have more sort of first pass maps that are still far a substantial step forward based on what we have. And as Rebecca really nicely highlighted, there is, of course, a huge variability among sort of voluntary and compliance protocols in how they treat these, but most of them don't tend to have spatially variant data and data that include the impacts of climate change. And we did an assessment of some of these, particularly California's protocol, and found that the existing buffer pool is far, far too small by a factor of 3 to 8 to actually include these. So this is a big pitch that we need to update these protocols based on independent and consistent data sets. Now, there's a lot of complexity, as Christopher really highlighted, and I think that's a good discussion topic for this panel. So my summary is, I think we really need more rigorous risk assessment, and almost all of these protocols greatly underestimate climate risks. This ties into a need for transparency and accounting for new science. And then I would maybe echo, and Rebecca put this far better than I did, but durability fundamentally has to match the claim made, and offsets require this exceptionally high bar of permanence because we're asserting a fungibility between fossil fuel emissions in the atmosphere and forest carbon storage. And there are ways to think about the durability possible in different systems and the claim made, including a contributions approach that can help us still invest in forests and their climate benefits, but potentially not make these really challenging, incredibly high bar claims about permanence. So with that, thank you, and I'm excited for the discussion.
All right. Well, thanks to each of our panelists. I think that, given what we saw with first Christopher and then Rebecca showing these challenges that we've got in terms of variability and the way things are accounted for in these different protocols. And then following up with what Bill showed in terms of variability in risk. Why don't we kick off with the question, what are the big permanence risks that we see, and then how do we expect them to change given projected climate? And so anyone want to jump on that, or would you like me to? Okay.
I'm happy to take a first pass. I mean, generally for US forests, fires, drought, and insects are the big three that we worry about. I think there are some important risks of storms, hurricanes, potentially floods and landslides. But these are, if you look at the overall carbon cycle risks in the US, I think those are the biggest three. Fire is the one that's obviously a number of offset projects have burned in the past 5 years. Globally, I think you have to start better factoring in more of these storms. And of course, the sort of social and governance risks become a lot bigger in other countries, and that's not a climate change risk per se.
Thanks, Bill. Rebecca or Christopher, anything you want to add to that? No? Okay. Rebecca?
I'll just, I mean, I agree. I think there's the physical risks, which Bill mentioned really well. And then there's also just sort of the risk of keeping these projects going. And I think as we're thinking about really increasing the rigor of the science and tying to real buffer pool contributions, we also just have to be aware of, the cost to people being able to keep these projects on the line, because if they fall through, that's a risk to permanence of the carbon stored as well.
Could I just quickly add in on that too, Matt? I mean, I think it's true that larger buffer pools are going to lead to lower incentives for these projects. But I think there are two flip sides to keep in mind, right? One, having science-based buffer pools or durability claims is going to dramatically increase the credibility and sort of help shore up a very foundering market. And two, having kind of independent and consistent tools that are funded by, I don't know, universities or NGOs or think tanks, should hopefully dramatically decrease some of the transaction costs and barriers to getting projects off the ground. And so I think it's important to realize there are many reasons that we probably want better permanence data sets and tools out there in the space.
That's a great point. And Christopher's graph that included CCX, I remember when CCX was on its way out the door, I think it was trading at 25 cents a ton. So the value or the amount of money that could be earned from developing a ton of carbon offset was pretty low. And so I'm curious, Christopher, given your take or given your, your backward look to '09 and what was going on in the early days to where we are now, how much do you think there is to gain from, improved tools that like kind of lower the costs of developing these projects?
Oh, that's a really good question. Because there's the science side, and then there's the person doing the science side of that answer. And so I fully agree that we have improved capabilities, improved data sets, and we should be doing a better job informing the market with those tools and data sets. But at the same time, I can't tell you how many meetings, workshops, whatever, been involved with over the years where it seems like it's the same conversation it was 20 years ago. And so I've just been struck with this. If I can generate a scenario that has 10 possible answers, how do I know, even if each one is science informed, which one's the right one? And so I can go conservative and make sure the system is airtight, but it's really out of reach for a number of landowners who may be willing, but just unable to make the numbers work. And that gets to, I think, the point that was just made of, if the system is not necessarily profitable, what do we say about people who walk away after 5 or 10 years because of other economic circumstances that arise? And so that's kind of one of the reasons why, given the climate crisis and where we are, I've really start to come around a little bit on we should be encouraging carbon, and that's more of a normative than a positive statement, but we should be encouraging carbon in whatever ways we can so that we can generate these benefits, but to think about ways that we might think differently about how we go about that. So it's not a 100-year project on a couple thousand acres that has people on the ground measuring trees every year, every other year, but rather something different. And frankly, I think that's where a lot of the new stuff that we see. I mean, frankly, if social media can sell me shoes that I didn't know I wanted, and now I definitely think I need, and Amazon can deliver wasabi covered peas in a matter of 2 hours, that we should be able to figure out ways to deliver carbon from people who have it to people who want it. And I don't know the answer to that because that's not my space, but it just seems like after 20 years of trying to engage in this, I keep coming up with the same one of I can defend these numbers, but I can defend those numbers too. And so how do I know which one is the right one to use? And that kind of, steps out of that comfort space where I really know what to say. I said a lot
Thanks.
there. I'm sorry.
No, that's great. Melissa, did you have a question?
I actually do this time.
Okay.
This is for Chris. I appreciate your longstanding participation in this field, and you talk about how sometimes the same conversations are happening, and they happen until they don't have to happen anymore, right? But just for the sake of understanding what evolution looks like, is there any conversations or anything that has been resolved over time, like successes or wins?
Geez, that's a tough one. Honestly, and I don't want to take this in a space where the webinar is not meant to go, given the topic, but I feel like a lot of nature-based solutions are having this problem. Even things that are based on, say, ethanol, like, the whole indirect land use question, it was a great idea until it wasn't. And I feel like it's just it comes with the territory of trying to understand how do you count the discrete benefits from a diffusely managed land use that's governed not only by physical parameters, but economic and social too. And so that's a good question. That's a really good question, and I'm not ready to answer it. I want to say yes because I'm still here working on this, and there's still, I think, reason to be, but I'm having a hard time picking a good answer. I don't know. Rebecca, Bill, and Matt, any thoughts on your side?
I'll just throw out there as an example. There's greater social will than there has been in the last 20 years, I believe. And in my experience, there is more openness among groups of people that have not been there before. And so that being, I think that social will part there, which is diffuse, I've seen measurable differences and improvements.
Great. So I want to pivot just a tad. So Rebecca, the results you presented from the working group, one of the things that you highlighted there was really that that monitoring time from, very much not rigorous, short tenure to 100-year after the end of the project in terms of monitoring how long that carbon is located, and then some of the other aspects of rigor and how those rated more highly if for certain protocols. I'm wondering, are there particular areas where tool development would help improve rigor that were identified from that process? Are there specific areas that we need to start investing a lot of scientific attention into in terms of permanence?
Yeah, so I think, that was like a snapshot of some very complex processes boiled down to a few words on a slide. But all of these different protocols have very different approaches to getting to that risk number, and it depends on the amount of time. And so one thing that sort of our group arrived at as being really important is just taking a little bit of the guesswork out of that from a developer perspective and having more standardized tools. I think this kind of goes to what Christopher was saying. Also, if you can get a whole bunch of different answers and you can defend them all out of these different protocols, that's difficult, but in some ways it's important to have an authoritative answer to look to, so that we're comparing apples to apples across projects. I think that would really advance things a little bit. It's understandable that these approaches have bubbled up differently from different corners, but I do think having some ability to say a credit is a credit across these different issuing bodies would be a real step forward, in having these sort of independent data that's spatially explicit, that's referenceable, that doesn't require the developer and their team to kind of come up with this data set, and would disallow cherry picking if that's happening, but also just provide this information for those who want to do a robust job. So I think having these standardized tools that are widely referenced across programs would be really helpful. I also think having a standardized time of monitoring, or at least some signal of how long this credit is good for, that's associated with the credit itself, would be really important, because as Bill mentioned, the permanence issue is important for the claim that's being made, and different claims might not require 100 years permanence or the same degree of permanence. But the way the system is set up right now, that information is sort of just all lost in a jumble, and everything gets sold as a credit, even though there's really, really important differences under the hood.
Great, thanks. And so I want to drill a little bit further down into that with you, Bill. So you've done, you presented some work on both, like, the big three in North America, and then disturbances, and then looking globally. So from your perspective, having looked at different data sets to kind of evaluate these permanence risks from disturbance, what's the potential for us to have like a global data set, or do we need to account for geographic specificity in terms of data availability and stuff like that?
Yeah, thanks, Matt. It's a really interesting question. I think, well, satellite data is advancing pretty rapidly, and we're starting to get these global data sets of what we used was a basically stand clearing disturbance, and that can be partitioned fire versus everything else. But we're getting, with machine learning and better satellite data, we're getting better at that attribution of like, yeah, well, it looks like it was a drought event here, or it looks like it was people that went over and cut this forest down. So our data is getting better and better. And I am optimistic that maybe in the next 5-8 years, we'll have pretty decent maps. That said, ground data like FIA is really, really powerful, right? Having boots on the ground, measuring trees and assigning what killed trees is really, really helpful. And so our thinking has been that basically we can use satellites to get a first pass globally. And in fact, when we take our global maps and compare them to the US maps, they're decently close. But when you have good inventory data in countries or plot data, I think that's really helpful to build kind of more rigorous data sets. One other thing I'd just like to flag, and I agree with everything Rebecca just said, is that there's this fascinating intersection between additionality and permanence that comes in the buffer pool, because the buffer pool gets capitalized from additional credits that are often leakage adjusted, right? So that's the amount of credits flowing into the buffer pool. But carbon losses can come from anywhere on the landscape. And so when you're trying to calculate the size needed on the buffer pool, it's this really complicated set of assumptions that also really depend on the additionality of the individual project. If a project is, 2% of the carbon on the landscape is considered additional, it's got a really small buffer pool contribution. If 50% of the carbon is considered additional, that's a bigger contribution. And so anyway, this is all just to highlight that we like to think of these as sort of separate issues, but they interact in really complicated ways that makes it hard to come up with, give me a buffer pool of 30% in this forest and you're fine. It's hard to kind of come up with those calculations across projects and across jurisdictions.
Thanks. I think, this really kind of highlights to the temporal nature of all these dynamics that we see in forested ecosystems. I think a lot of these offset systems, we're tending to, view these discrete periods of time and tied to a specific location on the landscape, when in reality, a lot of these processes are happening over long time periods and over large spatial domains. And I think, so given that, in the permanence challenges that we expect from changing climate and changing disturbance regimes, how should we be thinking about the time horizon and site specificity of forest carbon projects? We've got both compliance and voluntary markets, right? So, like compliance, like the California Air Resources Board, and they're part of a system, that's looking at carbon emissions across a regulatory system. Voluntary, where anybody can go buy a permit, an offset, like you take a flight and you can buy an offset. And then there are this idea of contributions approaches, where people are not necessarily making a claim about, some effect of investing in forests on their overall organizational carbon footprint, but that they're allocating resources to helping improve or increase carbon storage on a landscape. And so I'm wondering, why don't we start with you, Christopher? How do you think we should think about time horizon and site specificity?
I don't know, Matt. I just, I mean, I really, really 100%. I mean, I was trying to figure out what the hand gesture for 100% agree is when we're talking about matching claims. And I think that's a big part of it when we go from project-based, offset-based type work to let's just encourage more carbon across the landscape and reward those who are doing it. That's really where I've kind of come to. I still think it's fascinating to be thinking about the way these projects are designed, but honestly, where my research is now is all on the, if you set it 100 years, what does that mean for the incentive to participate? So I'm focusing less on the dynamics of the system and more about the incentives to the project and the person that's developing that project. And that's one of the reasons why I think in having some other conversations with, say, small scale real estate developers who are interested in somehow doing something different but don't know how, and maybe some of the stuff they could do could have carbon benefits through the way they manage the landscape through the construction process. How do we somehow engage that space? And I don't have an answer for that. So again, I don't want to take things off into left field, but again, I'm really interested in this one, making sure that the system's not overpromising, but two, figuring out how to design systems that let people play in ways that allow them to make a contribution, whether that's through an airtight offset system or whether it's through, small, slightly encouraged tons here and there.
In
Thanks, Christopher.
economics, oh, sorry, I was going to say in economics, it's called a nudge. You know, you create a pathway for people to adopt more sustainable behaviors without having to be overly work and conscious in doing it. Yeah.
Would you like to add something to that, Rebecca?
Yeah, sure. If we're going off in this direction, I'll add a little bit to it. Because I agree. I think a carbon offset model is one way to incentivize these kinds of practices, and there are other ways, and they're maybe not as developed, and they're not perfect, and there's a lot of work to be done to figure out how to get them going. But you know, in agricultural systems, we know that there are opportunities for payments to adopt certain practices in, you know, crop cultivation that have less intense, you know, carbon emissions. And by doing that sort of incentive that's about adopting a practice, and you know that there is ultimately a benefit to that. Maybe we don't know how much of a carbon benefit there is. Maybe we don't know how long it's guaranteed to last, but we're again, in a different context, nudging the system in that direction, in that model. And there's no one claiming that carbon on the other side. And so I think that's really the key issue, is if we could get a stronger handle on what sorts of claims can be made, what kinds of accounting is happening with this mix. The problem I see is the mixing of credits with fossil emissions accounting. In compliance systems that currently exist, we don't have that problem as much, because we're talking about industries that have reporting requirements for their fossil emissions. And so that goes in sort of one column on a ledger, and offsets go in another column on a ledger. But when we have things openly in a voluntary carbon market, and there's not only is a credit from a 40-year monitoring plan the same as a credit from a 100-year monitoring plan from a forest, it's also counted the same as a ton of natural gas burned and emitted to the atmosphere. And so I think if we had a better handle on how we are counting and tracking these emissions and where they're coming from, removals and reductions of emissions from forests, we could also get around a lot of these problems and lean into these more activity-based management approach-based incentives. Just as long as we are, you know, again, comparing apples to apples, or, you know, oranges and bananas where appropriate here. We're keeping things accounted properly based on the characteristics that they have in terms of what those emissions will do to the atmosphere and for how long.
Thanks, Rebecca. Bill, you got thoughts on time horizon and site specificity?
You know, I mean, I really like a lot of what Rebecca and Christopher just said. I think, you know, something that I just flagged in the Q&A that's worth thinking about is how short is beneficial. And there's been some really nice work kind of looking at sort of the benefits of temporary carbon storage. You know, what if we don't want 100 years? What if we want 20 or 30 or 50? And a lot of it comes down to, when did temperatures peak globally? So first of all, you have to do this from a sort of economics approach in terms of kind of standardizing things, because physically they're not identical, right? Carbon in the atmosphere is, large parts of it last for thousands of years. And the key part is you have to keep carbon stored in your landscape broadly. So maybe that's your portfolio of projects through peak warming. And in the best case scenarios that we are not on, peak warming is sort of 2070s to 2090s. In the types of scenarios we probably are on currently, it's at least 2150. So there is, even temporary carbon storage, we do have to be thinking temporary is not 10 years or 20 years, unfortunately. So that's, but again, this is all dependent on the claim made, right? And this is what I think we've touched on a couple of different points.
Thanks, Bill.
All right, I'm gonna hop in here with some questions that you'll fielded in the email. This is a buyer side question. So a lot of these conversations are oftentimes like revolve around the sellers of credits or the projects actually are. So as a buyer of carbon credits, so what does it say? It's a company, they have a variety of maybe goals like ESG goals, or wanted to meet some sort of net zero goal, whether it's from like shareholders or their board of directors. As buyers are looking into carbon offset projects that they might want to purchase credits for, what should they consider regarding like the risk of reversals, specifically from disturbance, right? We talked a lot about earlier, there is that risk of reversal from disturbance. So if you're like a buyer and you want to ensure the permanence of the credits that you're investing in, what should you be looking for in a project to try to reduce that risk?
All right, who wants to tackle that one?
I could take a very rough stab. I mean, Chad, it's a really great question and a really tough one to answer because there's no single authoritative like go check X box. I mean, there are ratings agencies, but what they assess for risk varies and is proprietary. So they probably have some information, but we don't really have a clear sense what that is. Rebecca's paper, when it comes out, I think will give a nice sense of like, these are the components that really matter. And you could look at a protocol level. This protocol does this well and this not well. And then ultimately, I mean, generally, the climate risks are larger where it's stressful to be a forest. And so the climate risks are larger where it's dry, where there's higher fire risk. You know, this unfortunately large swaths of the Western US are probably not going to be that stable for forests over 100 years. So there are ways to kind of use some of the scientific literature out there to screen, but there's no perfect way to say, you know, this project is an A+ and this project is an F robustly right now. And there's big transparency gaps as well as to what projects make available, which is a huge need for sort of independent evaluation.
Is there any research papers that have kind of overlaid, like in some sort of like regional, you know, continental level of like all the forest stressors and then where, you know, the hotspots are or anything like that? When I mean like health stressors, you know, versus other.
I don't know if any of you are aware of like a multi-stressor paper, but you know, I can think of papers where they've looked at things like, you know, climate stress, so drought, you know, insect. It's been primarily individual stressors. Sometimes the climate space will be broken up by temperature and precipitation, but by and large, I think at most there'll be two factors, but there's, you know, also a million papers published every year. So,
I mean, we did drought, fire, and insects all together in this set of work. And so you can kind of overlay those. We don't have wind or storms or any of those disturbances in them. And so I think there's not a very, especially at large scales, this was just in the contiguous US.
I also think it's worth pointing out though, I mean, from the perspective of permanent credits. So from a buyer purchasing credits that are going to last, you know, for a timeline that is appropriate for their needs. And Chad, you mentioned different goals, like net zero goals are one thing, but ESG goals may be different, right? And there could be projects in these places that have high risks to forest health that are really good and effective projects and getting management into places that need it to resist some fire risk or insect management risk, right? So I wouldn't say that companies should not purchase or not fund projects in those kinds of areas where forest health is at risk. In fact, interventions in those areas could prevent additional losses. And that might be, you know, in some ways, an avoided emission is a more permanent is a more permanent way to store carbon, although it's never guaranteed. So I think aligning a buyer's goal with their purchase is really important. And if you're looking to invest in ecosystem resilience, you're going to have a really different set of parameters that you want to screen for than if you want to try and make a net zero goal with a carbon credit.
Yeah, I want to thank you, Rebecca. I want to jump on this. So I think that one of the things that's important for all the attendees of the panel here or the webinar to walk away from is all of us on this are real big proponents of, you know, investment in forests, right? For climate regulation, for other ecosystem services, for the fact that I love big trees, right? And so it's like forest conservation is a really a valuable thing. And I think probably the thing that I would like people to take away from, and based on the conversation that we, the panel, had beforehand, that we would like all of us would like you to take away is the fact that, you know, there's a big difference between investing in carbon storage on a landscape from the perspective of you're trying to, you know, the ESG aspects that Chad raised, like Rebecca was saying, versus, you know, I'm getting on a plane and I'm pumping a bunch of carbon high up in the atmosphere and I'm going to neutralize that, right? There's a big difference from the perspective of the way we think about forest-based carbon storage and what it means in terms of net climate benefit. And so I think that, you know, to echo what Rebecca was saying, and that what I think everybody's been saying is that, you know, we need to see increased money allocated to these landscapes, right? Forest conservation, forest restoration, all these sorts of things. And that's really important for helping to regulate the climate system. But it might, you know, there's some challenges that need to be overcome before we have a ton of forest carbon being fungible with a ton of unburned fossil carbon.
Great. Thank you so much, Matt. And I think that's a really good spot to kind of leave the webinar. I just shared again our upcoming schedule for the 5 remaining webinars we have coming up. But before that, I would like to again thank our panelists so much. So Matt, Bill, Rebecca, and Christopher, thank you all for taking the time and bringing your expertise and having a nice conversation around permanent forest carbon offsets. For everybody in attendance, again, we have 5 more panel webinars. Our next one is February 25th, which we will be joined by Adam Dagno from University of Maine, Greg Latta from University of Idaho, Lily Caraca from Cal Poly San Luis Obispo, as well as Marga Fernandez from Penn State University. And we'll be having a conversation on forest carbon additionality as well as baselines. You can register for that webinar with the bottom QR code on the screen, as well as join the Forest Carbon and Climate Program listserv to find out about other events that we have coming up throughout the year. So again, thank you to everybody for joining us, and I hope you all have a great afternoon.